Hello everyone. Today we'll be continuing from where we left in our first lecture regarding cam and follower. In the first lecture, we had discussed about the classification of cam and follower, and then we discussed about the various terms that will be used in the case of cam and follower, and then we discussed about the type of motion of a follower. This particular lecture we'll be discussing about the methods to draw a cam profile. So I expect all of you to have your drawing instruments ready. Mostly we'll be using the compass, protractor, set square, scale, pencil. So I hope all of you are having these things with you. And the drawings in this particular chapter will be drawn according to the measurements. The cam profile is related to the motion of the follower. To draw the cam profile, you must know the motion of the follower, and based on the motion of the follower, we first have to draw the displacement diagram of the follower. From the displacement diagram, we will be drawing the cam profile. This is the procedure to draw the cam profile. That is, first you draw the displacement diagram of the follower, and then from the displacement diagram we will be drawing the cam profile. Now we will look into what is a displacement diagram, how a displacement diagram of a follower is drawn. This slide shows the different types of displacement diagram. As I have already told you, the motion of the follower can be divided into 4 different stages. The first stage is the outward stroke, where the follower moves from the lowest position to the topmost position. Then the second stage is the first dwell period, where the follower remains stationary. Then the third stage is the return stroke, where the follower moves from the topmost position to the lowermost position. And the fourth one is the final dwell period, when the follower again remains stationary. During this complete motion of this follower, the cam rotates an angle of 360 degree. In a displacement diagram, the x-axis indicates the cam angle, that is the one revolution of cam in degree, and the y-axis indicates the displacement of the follower. In this particular figure, this shows the displacement diagram of a follower which undergoes uniform motion. That means the region AB1 indicates the displacement diagram when the follower undergo the outward stroke. And then region B1C1 is when the follower is in its initial dwell period. And the region C1D is when the follower returns back to the initial position, that is the return stroke. And the region DE is the final dwell period. You must understand that during the motion from A to B1, that is from the lowest position to the topmost position, and from the topmost position to the lowest position, that is from C1 to D, the follower has undergone uniform motion. That means a constant slope. The other displacement diagrams are also similar. The only difference is regarding the type of motion. In the second diagram, the follower undergoes the outward stroke and the return stroke with a simple harmonic motion. That means, so this is the outward stroke cam angle. This is the return stroke cam angle. And in between the outward stroke and the return stroke, you have this is the first dual period cam angle, during which the follower will be at the topmost position, and after the return stroke you have the second dual period, during which the follower will be at the bottommost position. Similarly, the third diagram, in which the follower moves with a uniform acceleration and retardation during its outward stroke and the return stroke. Uniform acceleration and retardation means that in a single stroke, the follower will undergo both uniform acceleration and retardation. That is, for example, in the case of outward stroke motion, during the first phase of the outward stroke, that is till here, it will be uniform acceleration, and thereafter it will be uniform retardation. Similarly, during the return stroke, during the first half of the return stroke, that is from here to the midpoint, it will be uniform acceleration, and then the rest of the motion, it will be uniform retardation. Rest all are similar to the previous two types of motion. So now we are going to discuss how to draw the displacement diagram and thereby draw the cam profile. Before that, when you are given a question, what are the parameters you need to see, or what are the parameters that has to be given in the question so that the question is complete? Mostly in any question, these are the three parameters which are important, which has to be given. One is regarding the motion of the follower, then is the type of surface in contact with the follower, and the third one is the type of path of motion of the follower. We have already discussed about the type of motion of the follower. Regarding the surface in contact of the follower, we will be discussing only these two types, that is regarding the knife edge follower and roller follower, and regarding the path of motion of the follower, we will be discussing about a radial follower and offset follower. You must keep in mind that when a question is given, for that question to be complete, these three parameters should be specified. That is, one is the motion of follower, then the type of surface of contact of the follower, and the path of motion of the follower. There is a small instruction on how to keep your notebook when you do the problem. You can hear that. Then we will discuss about the problem. When we do the problem, you can write the question on the left side of your notebook, and on the first right side you can draw the displacement diagram, and the cam profile can be drawn on the right side page of on the other side, like in this way. Okay. That means here you write the question On the left side you write the question. On the first right you draw the displacement diagram, and then on the second right you draw the cam profile. Now we will discuss one question on cam profile. I prefer that you write this question first in a fresh page. I will read the question. A cam is to give the following motion to a knife edge follower. The outstroke is during 60 degree of cam rotation. Dwell for the next 30 degree of cam rotation. Return stroke during next 60 degree of cam rotation, and dwell for the remaining 210 degree of cam rotation. The stroke of the follower is 40 millimeter and the minimum radius of the cam is 50 millimeter. The follower moves with uniform velocity during the outstroke and with a simple harmonic motion during the return stroke. Draw the profile of the cam when the axis of the follower passes through the axis of the camshaft. We will now go through the problem in more detail and check whether all the parameters required are specified. In this particular question, if you have read, you will find that the follower is moving with two different types of motion. That is, for the initial outward stroke, the follower is moving with a uniform motion, uniform velocity, and during that outward stroke, the cam angle is 60 degree. And after the uniform cam motion, for the next 30 degree of cam rotation, the follower is stationary, or that is the initial dwell period. And then after the initial dwell period, for the next 60 degree of cam rotation, during the next 60 degree of cam rotation, the follower will return back. That is the return stroke, and that is based on simple harmonic motion. And when the return stroke is over, for the rest of the cam rotation, that is for an angle of 210 degree, the follower remains stationary, which is the second dwell period. So this is the details of the motion of the follower for one complete cam rotation. Now regarding the type of surface in contact, it is given that the follower is a knife edge follower. And regarding the type of path of motion, it is given that the axis of the follower passes through the axis of the camshaft. So that means it is a radial cam follower arrangement. Now you can see here that this particular question is complete and all the parameters are defined. Also, in this question, the stroke length of the follower is specified. The stroke of the follower is 40 millimeter and the minimum radius of the cam is 50 millimeter. The minimum radius of the cam is 50 millimeter. The minimum radius is nothing but, according to the nomenclature, that is known as the base radius. Now, based on the given data, we need to now draw the displacement diagram first, and then from the displacement diagram we have to draw the cam profile. That is the procedure. First we will discuss how to draw the displacement diagram. From the previous discussions, you may now know that a displacement diagram is nothing but a graph which shows the position of the follower with respect to the cam angle. In a displacement diagram, the x-axis indicates the cam angle and y-axis represents the stroke length. To draw the displacement diagram, first you draw a rectangle whose width is the stroke length, which is 40 millimeter, and the length is the cam angle of 360 degree. To draw the length as 360 degree, you can use this scale, that is 10 millimeter is equal to 30 degree, according to which the length will be 120 millimeter or 12 centimeter. So for a length of 12 centimeter and width of 40 millimeter, you draw a rectangle. After drawing the rectangle, you need to label the x and y axis. X axis you label it as the cam angle, and the y axis you label it as the stroke length. Also, you need to specify the scale. The scale is nothing but the scale of the x axis. Okay, so that you please keep in mind. Now in this, the x axis represents the cam angle of 360 degree. Now this cam angle, that is this 360 degree, we need to divide into various regions of follower motion. For that, we need to divide this rectangle as per the outstroke, the first dwell period, the return stroke, and the second dwell period. The outstroke is of 60 degree. So you take this measurement as 60 degree, which is nothing but 20 millimeter, and you draw a vertical line from that point. Similarly, the first dwell period is 30 degree, which is nothing but 10 millimeter from this point. 10 millimeter from this point. So at that particular point, you draw a vertical line. And then after that, the return stroke is 60 degree again, which is nothing but 20 millimeter. So from this point, 20 millimeter. Okay, so at this point you draw the vertical line, and then the remaining is the final dwell period, which is nothing but the 210 degree. After dividing the region, you label it as I have done it, so that your diagram will look neat. After dividing the rectangle into 4 different regions, we need to label the points on the rectangle correctly. You can follow how I have done it. You mark this point as A, this as B, this point as C, this point as D, E, F, and G. This labeling is very important because it will help you when you draw the cam profile. After labeling, now we need to divide the outstroke region into as many equal parts. Here I have divided the outstroke region, that is the region AC, into 6 equal parts. AC is of length 20 millimeter. So that 20 millimeter you divide into 6 equal parts. and from each point on AC you draw a vertical line. That is, after dividing AC into 6 equal parts, you can name it as starting from 0 as 1, 2, 3, 4, 5, 6. Okay, so from each point, that is from 1 you draw a vertical line, from 2 you draw a vertical line, 3 you draw a vertical line, 4 you draw a vertical line, 5 you draw a vertical line, 6 you draw a vertical line. Already it is there. So like that. In the displacement diagram, you indicate this point as small f. As we know, the region AC is the outstroke region of the follower, and during the outstroke the follower moves with a constant velocity. And when a particle is moving with a constant velocity, its displacement diagram will be a line of uniform slope. So to indicate the displacement diagram of the follower during the outstroke, what you have to do is you have to join the point F with A. So this represents the displacement diagram of the follower during the outstroke region. So that is what I have drawn here. The line AF intersects the vertical lines from 1, 2, 3, 4, 5, 6 at points A, B, C, D, E and F. You can name this point as F prime. So now the line AF indicates the displacement diagram of the follower during the outward stroke, and F prime indicates the displacement diagram of the follower during the initial dwell period. During the initial dwell period, the follower will be at the topmost position or the topmost position of the stroke. Now we need to draw the displacement diagram when the follower is at its return stroke. During the return stroke, in the question, it is given that the follower is undergoing a simple harmonic motion. So for a simple harmonic motion, how the displacement diagram is to be drawn, so that we will see. For that, at the right extreme of the rectangle, you have to draw a semicircle with the width of the rectangle as the diameter. After drawing the semicircle, you divide the semicircle into as many equal parts as possible. Here I have divided the semicircle into 6 equal parts, and you label the divisions as I have done it here. Also, DE represents the return stroke region. The return stroke region also you divide into 6 equal parts, and you can label each point starting from point D, which is 6 prime, 5 prime, 4 prime, 3 prime, 2 prime, 1 prime, 0 prime. So similarly, you make the labeling. So again, I want to remind you that these labels will also be used when we draw the cam profile. Now from each peripheral point from the semicircle, you draw a horizontal line. That means from 1 prime on the semicircle, you draw a horizontal line. You draw a horizontal line. Okay. Similarly, from 2 prime you draw a horizontal line, from 3 prime you draw a horizontal line, 4 prime you draw a horizontal line, 5 prime you draw a horizontal line, such that each horizontal line will meet or intersect the corresponding vertical line, that is 1 prime. The horizontal line from 1 prime will meet the vertical line from 1 prime. Okay, similarly horizontal line from 2 prime will meet the vertical line from 2 prime. So likewise. So then you will see here that the horizontal line from 1 prime meets the vertical line from 1 prime, you name it as A prime. Horizontal line from 2 prime will meet the vertical line at 2 prime, you name it as B prime. Horizontal line from 3 prime meets the vertical line from 3 prime, C, you name it as C prime, and similarly D prime and E prime. And then what you do is you join all these points using freehand, that is starting from F prime, E prime, D prime, C prime, B prime, A prime and E prime, E. You join using freehand, and finally you will get this. So the line, the curve from F prime to E, the curve from F prime to E indicates the displacement diagram of the follower during the return stroke, which is according to simple harmonic motion. And once it reaches E, then the second dwell period will start, and which will be a horizontal line. During the second dwell period, the follower will be at the lowermost position. So what you see here is the displacement diagram of the follower according to the given question. When you draw the displacement diagram, you can use contrasting colors so that the displacement diagram is more differentiable. So I'll just, for your clarity, I'll just trace the displacement diagram so that you are not confused. So this is the displacement diagram. So this region is the outward stroke. This is the initial dwell period. This region is the return stroke, and this is the final dwell period, which will be the lowermost position. Now that we have drawn the displacement diagram of the given problem, now from this displacement diagram we need to draw the cam profile. This video will help you to draw the cam profile from the displacement diagram. In the question, the base circle radius is given as 50 millimeter. So with a radius of 50 millimeter, you have to draw a circle as shown in the figure, and after that you label the center of the circle as O, and then from the center of the circle you draw a vertical line. You draw a vertical line such that the line meets the circle at point A. Now this point A is known as the trace point. So what is a trace point? That we have already discussed in the cam nomenclature. Using this trace point, we will be creating the cam profile. After drawing the vertical line OA, now we need to divide the base circle into the 4 different regions based on the follower motion. That means the outstroke region, the first dwell period region, then the return stroke region, and the second dwell period region. As per the question, the outward stroke of the follower takes place during the 60 degree of cam rotation. So now you need to draw a line such that it is at an angle of 60 degree from OA. So as O as the base point, with respect to OA, you draw a line such that that line is at an angle of 60 degree with respect to OA. Similarly, from the line that we have drawn, you draw another line at an angle of 30 degree with respect to the new line that we have drawn. Similarly, you draw another line which is at an angle of 60 degree with respect to the previous line. In this way, we can divide the base circle into the various regions based on the follower motion. Also, after completing the division, you also have to mark the angle of inclinations like I have done here. Now we have divided the base circle into 4 different zones based on the follower motion. Now we will label it properly. So this point is C, you mark it as C. This point you mark it as D. This point you mark it as E. Okay. Excuse me. This point we will mark it as E. Small capital letter. Now the region AOC is this region is the outward stroke region. Region COD is the dwell period region, the initial dwell period. Region DOE is the return stroke region, and region EOA is the second dwell period region. So now what we do is we will divide like what we have done in displacement diagram. In displacement diagram also we have divided the outstroke region and the return stroke region into 6 equal parts. Similarly, here also we will divide the outstroke region, that is AOC, into 6 different parts. That is this region into 6 different parts. That means you take angle of 10 degree to divide it into 6 equal parts. Similarly, you divide the return stroke region, that is DOC, into 6 equal parts. So when you divide it, you make sure that you are extending it. Don't stop it till the periphery of the circle. You can extend it like what I am showing it here. For example, if I am drawing this division, you are extending it beyond the periphery of the circle. And regarding the labeling, we have already labeled A, C, D, E, and from A this point will be 1, 2, 3, 4, 5, 6, and here it will be 6 prime, 5 prime, 4 prime, 3 prime, 2 prime, 1 prime. And this labeling format or the notation
is the same that we have used in the displacement diagram, the same format. So if you notice it carefully, those points are adjacent. For example, if you see here, this is A, and this is C, this is D, this is E. So AC we are dividing it into 6 parts, and DE we are dividing it into 6 parts. Similarly, when you come to the cam profile, AC we are dividing it into 6 parts. AC we are dividing it into 6 parts, and DE we are dividing it into 6 parts. That is the reason why I have told you that you need to label it properly, because the same labeling system will be using it in the cam profile. Okay. Now that we have divided the outstroke region and the return stroke region in the cam profile, now what we do is you go to the displacement diagram, and here you have point 1. So in your compass you measure 1A. You take the measurement from the displacement diagram in your compass. You take the measurement of 1A in your compass, and then come back to the cam profile, and here you have 1. So with 1 as center, you mark an arc on this line, and that point will be A. Similarly, you go back to the displacement diagram. You take the measurement of 2B in your compass, and in the cam profile, with 2 as center, you mark an arc on this line, and that point will be B. So similarly, you complete all the other remaining points. That is points A, B, C, D, E, and F. To the outstroke side, you take the measurement from the displacement diagram onto the return stroke region also. That is, in the displacement diagram, you take the measurement 6' F' in your compass, 6' F' in your compass, and then come to the cam profile, and with 6' as center, you make an arc onto this line, and that point will be F'. Similarly, you take all the other measurements from the return stroke side of the displacement diagram, and then you will get points F, E', D', C', B', A', and E. E is already there. Once you complete the markings from the displacement diagram onto the cam profile, what you can do is you can join these points using freehand. That is, starting from point capital A, you join it using freehand. Similarly, bottom also, from E to F', you can join these points with freehand. F' can be joined using compass. With O as center, you can complete that arc because it's a circular profile. Similarly, you complete this circle. Okay, so what you get is the cam profile, and technically since it's a knife edge follower, A is the trace point, and the curve that you get is the pitch curve. And since it is the knife edge follower, pitch curve is same as the cam profile. So this is the cam profile for the question that is given. I request all of you to practice this question and see, because in the coming class we'll be doing a variation of this particular question. Okay, thank you.